Take a look at another problem. Again, we're factoring by greatest common factor. So let's take a look at the polynomial negative 14x minus 12x squared. Okay. Well, again, if you don't mind, let's take a look at our coefficients. We have negative 14 and we have negative 12. Well, actually, there are a couple of ways that we can go into this. We could go in and look at look at 14 and 12 and know that the only actual term that we could pull out would be 2. Okay? And then again, we would know that we could pull out, because we stated earlier, the lowest of our variables, which is x, because both the terms 14 and 12 has at least the value of x. But if you notice something, you see both are negative. So we could do that and then first pull out a negative 1 or multiply by a negative 1 to change the signs on the inside. Or we could just literally, from the beginning, pull out a negative 2. So let's do that. Let's pull out a negative 2 and then again put our parentheses and see how it works. So if we have a negative 2, we pull it out. A negative 2 divides into 14 a positive 7 times, because a negative in the negative is a positive. 2 in the 14 will give us what? 7. Then we take a negative 2 and but of course we have to bring down our x. We take a negative 2 and divides into a negative 12, and that's going to give us a plus 6x squared. So then we stop and take a look at, and we find out, wait a minute, we have x on the inside of our parentheses. So if that's the case, we didn't factor completely, and we can go in now and pull out an x from each term, and that will give us a negative 2x because it's the smallest, and that's going to be a negative 2 times 7 plus, and then when we take out x from x squared, that leaves us with simply x. Okay, so now we go and look on the inside and we see, well, it is actually factored completely here. So from the beginning we could have pulled out a negative 2x, and then we would have had no issues with like terms, with like factors on the inside of our parentheses. Okay, so let's take a look now at checking, and as we would simply check, remember what we said, to check we just use distributive property. So we got a negative 2x, and that's times 7 plus 6x. So we would take a negative 2 times 7, and that's going to give us a negative 14x, and then a negative 2 times a positive 6x, and that's going to give us a negative 12, and x times x is x squared. So again, our check answer comes back to our original problem, and we can be sure using this distributive property that we factored correctly. Okay, so now let's take a look at another polynomial, and this time we're taking a look at a trinomial. So I go ahead and mark this problem number 2, mark this problem 1, and problem 2 tells us we have 3x cubed plus 2x squared minus 10. So again, let's find the greatest common factor. So one thing you want to look for is, do all 3 of your terms contain a variable? And the answer is no. So if all 3 of your terms does not contain a variable, Now we go to our coefficients and we look at 3, we look at 2, and we look at 10. What are our factors of 3? Well, of course, our factors of 3 is 1 and 3. Then our factors of 2 is 1 and 2. And of course, multiple factors of 10, which is 1 and 10. We have 2 and 5. Now, as we notice with these lists, the only common factor we have is 1. And factoring out 1 will not change the way the actual polynomial look. So we can say that the polynomial cannot be factored. Okay, so that takes a look quickly at problem 1 and 2, but since we waste just very little time on those, let's take a look at the third problem. Okay, what about 5b plus 9b cubed? Well, again, let's see, can we find the greatest common factor? We look at 5, and the only thing we have is 1 and 5. We look at 9, and we have 1 and 9, and 3 and 3. So we see we only have only one that's factorable. But wait a minute, there's a b and a b cubed. So with our variables, we can go in and pull out the smallest of our variables, since both 5 and 9 contain the variable b. So we can pull out b, and then that'll be dividing, and that's going to give us b, and the b would be bring out 5, because that's 1 into 5 is 5, and b in the b is b to the 1 minus 1, which is b to the 0, which is going to give us 1, and 1 times 5 is 5, plus, and then of course 1 into 9 goes 9 times, and b into b cubed is b to the 3 minus 2 minus 3, which is going to give us 9b squared. Okay, so that seems to be completely factored. So let's multiply to check. We're just going to check our answer. Okay. Here we would have b times 5. So again, we're checking with b times 5 plus 9b squared, and b times 5 will give us 5b, plus b times 9b squared is going to give us actually 9b cubed. So answer goes back to our original answer, and we factored completely. Okay, so we'll work, let's work a couple more, and then we'll go on. So let's go with problem, actually we did 3, so let's look at a different problem, and then we'll move on to, so here let's go with problem number 4. Again, you're going to have the same concept, so I do believe that after a couple problems I think you have in there. So now let's take a look at 9d squared minus 8 squared, and we want to look at our factors. So we're looking at 9. Our factors are 1 and 9, 3 and 3, and 8 of course is 1 and 8, and 2 and 4. No common factors there. And then we'll look, and if we notice, we have d and no variable. And I know you're probably thinking, well, hey, we have the exponent, the powers of 2. No. These exponents are not what we're looking for here. So, of course, since we only have factors of 1 here, we can say that this polynomial cannot be factored further. Okay. You just have to be careful when you're looking and make sure that there is a greatest common factor out of both of your terms inside. Okay, we will try one more, and then I will leave it up to you to go inside of the book and work. Okay, so let's look at problem number 5 here, and let's take another binomial. Negative 18y cubed minus 7y squared. And again, we will go and look at our factors. So let's look at our factors of 18, and we have 1 and 18, 3 and 6, well, 1 and 18, 2 and 9, 3 and 6. And 7, we only have 1 and 7. Okay, but we do have y and y. So now here's a time when we want to take, since both coefficients are negative, let's factor out a -1 here. Before we didn't do it, but let's do so here to show you how it works. So you got a -1 we're going to factor out, and if we factor out the -1, -1 into a -18 goes 18y cubed times, and a -1 into 7 -7 goes a plus 7y squared time. Okay, now we still can factor out y squared from both terms. Since both terms does have y, we can factor out y squared because it's the smallest term. But as we do that, we must understand, we must carry our -1 along with us. Okay, so we have a -1, and then what we want to do here is put that inside of a bracket, and in here we're going to put y squared, and in a bracket 18, and plus, and out of y squared we can pull out, actually we need a y here, and then here we can just pull out y squared from 7y, and that's just going to leave us 7. Close this, and then we close our second bracket. So here that tells us that we have out of here y squared -1 times y squared times 18y plus 7, and we can close. Now, as if we can use again to go back and distribute this property out, and you notice 1 times a -y will give us a -y squared times 18x plus 7. Okay, and that tells us that we are completely factored. And of course, again, to check, we just multiply -y squared to, make sure I say x, but that's y, that we multiply -y times 18y plus 7y, and then we'll come back to our original problem. Okay, so that about does it. It's not really that complicated with factoring out the greatest common factors. If you're a little still maybe not so ready, or what can I say, that you're not, you don't feel comfortable at this point, just go back and look at some of the basic greatest common factor and prime factorization inside your textbook, and you should be fine. Okay, well, we'll see you next time when we talk about factoring with grouping.